This is going to be the first video of Chapter 3, Introduction to Organic Compounds. We're going to start by introducing some basic functional groups of inorganic compounds. First of all, we know that organic molecules are just a lot of carbons or hydrogens or other heteroatoms covalent bonded together. And then based on each group of atoms, we can find different functional groups in the molecule. Now, usually the functional group is a group of atoms in an organic molecule that has very strong and unique chemical features that determines the property or physical and chemical properties of this molecule. For example, a hydroxy group is a functional group that defines an alcohol. In this case, hydroxy group is covalent bonded to any carbons in different forms. You can see the examples down here. Now, actually, there are more different kinds of functional groups based on their structure feature. And let's take a look at the slide that summarize different functional groups. Now we're going to start by different type of atoms. First of all, if you're looking at just carbon and hydrogen based functional groups, you can see the simplest one would be just carbon-carbon single bond, but nothing else. We call this kind of functional groups alkanes, which is obviously the most commonly seen type of bonds or functional groups you're going to see in any organic compounds. Similarly, you can see carbon-carbon double bonds and carbon-carbon triple bonds are named as alkene and alkynes respectively. They all start with ALK, with different suffix of ANE, ENE, and YNE, which defines three types of carbon-based functional groups: alkane, alkene, alkyne, which is actually what we're going to focus on in the first half of organic chemistry. And now we're going to look at functional groups involves heteroatoms, such as, for example, the hydroxy group directly attached to a carbon, that's going to be alcohol. Here's something I need to emphasize. It's very important to recognize different composition of the functional groups as well as what kind of atoms they're attached to. Usually we're saying the functional group is attached to a carbon. If they're attached to a different atoms other than carbon or any other heteroatoms, usually there are different functional groups. Now when you have a hydroxy group, or in other words, this oxygen is a sp4 tetrahedral oxygen, single bonded with a carbon, on the other side single bonded with a hydrogen, and then we say it's an alcohol. If we slightly modify this oxygen by changing the hydrogen to another carbon, then we say this is an ether. Now, of course, when we say ether, we mean this functional group ether that belong to another, maybe bigger molecules. For example, the carbons on both sides of this oxygen, we didn't really define what they're attached to, but they might be attached to any other structure feature of the molecule. But as far as the functional group of this part, we call it ether, because this oxygen is bonded to carbon and is bonded to another carbon. Notice this kind of difference will help you to identify different functional groups. The oxygen attached to a hydrogen and another carbon versus oxygen attached to two carbons are different between alcohol and the ether. If we replace the oxygen with nitrogen, we would get carbon nitrogen, and with some of hydrogens on nitrogen, that would be called amine. Now again, this nitrogen is sp3 nitrogen. In other words, we have to follow the normal bonding pattern of nitrogen here, which possess 3 sigma bonds. So that's why in the amine, the functional group actually is NH2, whereas the alcohol oxygen is only one hydrogen. Just reminding you that the commonly seen binding pattern of the oxygen is 2 bonds with 2 lone pairs, and nitrogen is 3 bonds with 1 lone pair. And it shouldn't be surprising that there are 2 hydrogens next to nitrogen, and there's only 1 hydrogen next to oxygen. Another group, a big category of functional groups, is based on this CO double bond. The CO double bond is called carbon. The CO double bond is actually called a carbonyl group. Now, this kind of carbonyl group, on the carbon is sp2. The oxygen is also sp2. This sp2 carbon is attached to an oxygen with double bond, and it has two other single bonds, which will complete the four bonding bonds around this carbon. Now, these two sigma bonds can be bonded to different things. The X and Y here, based on what they are, they can be different functional groups. For example, if one of the attachment on this carbonyl carbon is hydrogen, could be 1, could be 2, then we say this is an aldehyde. The simplest aldehyde, the smallest aldehyde obviously is the formaldehyde, which is this one. Now, this is also aldehyde. If you replace the hydrogen on the carbonyl carbon with carbons, both of them, then we say this is a ketone. The simplest ketone will be obviously the acetone. Of course, if you extend this carbon with more carbons, then that will be different, larger, different ketones. But it's still going to be ketone if you look at this part of the molecule. Now, still based on the carbonyl group, it's on one end is carbon, on the other end is actually a hydroxy group. Yes, the same hydroxy group in the alcohol, but this is not alcohol anymore. This is a carboxylic acid. Remember I said about the same hydroxy group attached to different groups, it will be different functional groups, and this is one example. If the hydroxy group is attached to a carbon with nothing else on it, when I say nothing else, I mean with no other functional group on it, then it's an alcohol. It could be another carbon, could be carbons or hydrogens. Then that will be only alcohol. If the hydroxy group is attached to a carbonyl group specifically, then this can only be carboxylic acid. Now, keep in mind, hydroxy group is actually oxygen with hydrogen single bonded. Now, if we replace, based on the carboxylic acid, replace this hydrogen with another carbon, we're turning carboxylic acid into ester. So in other words, all of the other structure feature from carboxylic acid has to be the same in the ester. For example, ester, carbonyl group with oxygen and another carbon instead of hydrogen. Now, also based on this carbonyl group, if we keep the half of the acid look like a ketone, but the other attachment is not a carbon, is similar to amine with NH2, sp3 nitrogen, then we say this is amide. It's called amide. That's similar to the ester, carboxylic acid, except that replacing the OH or OC with NH. Now you can keep in mind this nitrogen has to be sp3 nitrogen, and that's it. It doesn't have to have two hydrogens. For example, you can have two other carbons attached to this nitrogen. This is still an amide. Again, amide is the name of the functional group. It's not the name of this compound. This compound, the nomenclature of the whole compound, of course, is determined by the actual composition or the other structural features. Similarly, all of these names are the functional group name. They represent a group of compounds containing these functional groups. They are not the name of the compound. And here's another slide that shows very similar information, but shows a little bit more detailed or in some more subcategories of within the functional groups. We can look at these by looking at different format of examples or represent of the different functional groups. For example, alkanes basically can be seen as any carbon with 4 sigma bonds. Alkenes will be any carbon-carbon double bond. Again, it has to be double carbon-carbon double bond. It cannot be any other heteroatoms. Alkynes can only be carbon-carbon triple bonds. The CN triple bond is called a nitrile. X, usually in the organic chemistry, representing the halogen atoms, such as fluorine, chlorine, bromine, or iodine. If the X or halogens attached to a carbon, here R representing any carbon-based groups, could be alkane, alkene, or alkyne. If halogen atoms attached to a carbon-based functional group, we call it alkyl halide, or simply saying halide. Again, R here representing any carbon-based functional group, alkane, alkene, or alkynes. If two carbon-based functional groups are connected with one oxygen, then we say it's an ether. One thing you got to be careful is that R and R here can be different. They don't have to be the same. So sometimes people actually show the general format of the ether using R, O, R prime, showing that R and R prime, they don't have to be the same. Hydroxy group attached to a carbon-based function group is alcohol. And carbonyl group-based function groups including aldehyde. The feature is that hydrogen next to the carbon, or ketone, the feature is that two carbon-based functional groups attached to the same carbon, carbonyl carbon. Carboxylic acid is hydroxy group attached to the carbonyl carbon. Or look like ether, half of the ether, but attached to a carbon, that's a carbonyl carbon, so-called ester. Amide is a sp3 nitrogen attached to a carbonyl carbon. This N can be NH2 or NHR or NR2. Again, R here stands for any carbon-based functional groups. Amine can be an sp3 nitrogen attached to a carbon-based functional group, R, with single bond. On the other side, you have two hydrogens on the nitrogen. We call it primary amine. Or this nitrogen is actually attached to two carbon-based groups. We call it secondary. Or nitrogen is attached to three carbon-based groups. We call it tertiary amine. Keep in mind, all of the heteroatoms here, including halogens, oxygens, nitrogens, they have corresponding number of lone pairs. For example, nitrogen would have one pair. Oxygens, either alcohol or carbonyl oxygen, they all have two lone pairs. Nitrogen would have one pair, whether it's primary, secondary, or tertiary. Another group of function group is called aromatic hydrocarbons. Now, hydrocarbon meaning there's nothing else but the hydrogen and the carbons. The aromatic means, in Greek, means something smells pretty nice. In organic chemistry, this is what aromatic hydrocarbon look like, which is a 6-member ring with 3 alternating double bonds. So basically, you can see 6 carbons, and they are all sp2 carbons. And what's hidden here, or what's not shown here, is on each carbon, there's actually one hydrogen. You can see this carbon here has a double bond and 2 single bonds. And the same as this carbon, and this carbon, and this carbon. Now, we're going to spend some more time in the future talking about this type of functional groups. But any organic molecules containing this kind of structure, we call them aromatic compounds because they contain aromatic hydrocarbons. Now, more specifically, this 6-member ring with nothing on it with 3 alternating double bonds, which is called a benzene. If the benzene is attached to another hydroxy group, which forms alcohol, we call it phenol. Or if a benzene ring is attached to NH2, just like an amine, we specifically give a name, it's called aniline or aniline. Now, you do have to get familiar with these function groups so you can determine what kind of compound or what type of functional group a compound does contain. Let's take a look at the example. Of course, normally we wouldn't be looking at a structure, this gigantic structure, but this is a good example. Within the same molecule, we can look at different functional groups. You can pause the video here, try to identify different function groups yourself. And we can see there are multiple function groups contained in this compound. Let's take a look at one by one. This is alkyne. You can see carbons here and carbon here. On this carbon, there's actually a hidden hydrogen, which you don't have to show. This is obviously halide. This ring is benzene ring, aromatic. This is actually nitro group. Now you can see there are a bunch of carbonyl groups, but they're different. Like this one is carboxylic acid, because this carbonyl group is attached to an OH, whereas this carbonyl group with an oxygen is ester. On this oxygen, there's no hydrogen. It's actually attached to the carbon. That's why it's an ester. Now, this is a carbonyl group. Look like there's nothing here, but you can imagine there's actually a hydrogen here. Because hydrogen on the carbon usually are not shown, so that's why it looks like nothing. But you have to know there's actually a hydrogen. Now, this one is called aldehyde. Let's look at the other carbonyl group with a carbon and another carbon. So this whole thing is called a ketone. Compared to this one with a hydrogen, it's called aldehyde. The double bond here is called alkene. This is a hydroxy group attached to a simple carbon. It's called alcohol. This is an oxygen again, attached to no hydrogen but two other carbons. It's called ether, E-T-H-E-R. Try to differentiate the spelling between ester and ether. This is NH2 attached to a simple carbon. It's an amine. This is actually a primary amine. You can certainly look at any other organic molecules, try to practice how to identify the functional groups.